Well, Charles Marshall is a leading paleontologist from the University of California, Berkeley, and a leading expert on the Cambrian explosion. He also reviewed my book in Science in September of 2013, and as a result of that, a British radio host invited the two of us to do a radio debate on UK radio, and it was an hour-and-a-half debate, really substantive discussion, and I thought it was extremely interesting and lots of fun, clarified a lot of the issues, and I think people who want to know more about the book and about how the book has withstood criticism from really serious critics could go to my website and have a listen to that debate with Marshall and Meyer. I enjoyed the debate with Marshall very much. It was a very cordial discussion. It was a very substantive discussion. It was very scientific. I've read Marshall's papers for years, so I was excited just to have the interaction with him in real time. And that was actually very, I thought, constructive conversation. There were a couple of points that came out in the debate that I thought reinforced some of the written critique I've made of his critique. In particular, Marshall invoked self-organizational processes as a possible explanation for the origin of the Cambrian animal form. And I pointed out to Marshall in the conversation that I had watched a lecture of his that he'd given at Harvard in which he had made the same point, that there are these self-organizational processes, these processes that are very predictable, that produce certain types of patterns during animal development. But that he in his own lecture had pointed out that all of these self-organizational processes depend on pre-existing sources of genetic information. And that's a point that I actually made in the book, is that there are self-organizational processes that take place, but they take place only once you have a large infusion or a large complement of genetic and indeed epigenetic forms of information already present. And to that point, Marshall said, yeah, that's a fair comment. Another interesting point that came out in the debate with Marshall was the way in which he pushed the information problem back into the Precambrian. And he posited the possibility that there might have been a Precambrian pananimalian genome, as it's sometimes called, a vast store of genetic information in some ancestral form which hasn't been documented in the fossil record, but we might infer by some other means. And I pointed out in my response to him that might be the case, but that still doesn't solve the information problem, because you've just pushed the problem of the origin of information back into the dark recesses of the Precambrian, a cryptic history that hasn't been documented in the fossil record. But even if some ancestral form existed that had all the genetic information for all the animals that came later, you'd still have to explain the origin of those genes. Now, Marshall took my response to be something of a concession, that maybe the Precambrian animals might have evolved from some Precambrian common ancestor. And maybe it is a concession of sorts. That's certainly a possibility. It doesn't look very plausible to me from the fossil evidence or the genetic evidence, but maybe there was such an animal. But it's not really a concession on the key information argument, because you still need to explain those genes. And Marshall repeatedly presupposed but didn't explain genetic information. Now, this came up in a really interesting way in the debate at the very end, because Marshall kind of took me to task. He had a little gotcha point that he wanted to make. It was about a specific scientific factoid, a protein that I had discussed to illustrate the point that when you build a Cambrian animal, you need a lot of new genetic information, because there are a lot of new proteins that arise with these Cambrian animals that weren't present in earlier forms of life. And I mentioned one particular protein that is present with arthropods. It's a lysyl oxidase. It's a protein that's important for building the stout body structure of the arthropod exoskeleton. And Marshall had done a little research and had found that based on phylogenetic studies, you could infer that perhaps lysyl oxidase had been present in some Precambrian and hypothetical Precambrian ancestral form. And he said, you know, good scientists try to track these things down. They don't just say, hey, this looks like it was intelligently designed. And Meyer stopped the investigation too soon. He didn't track this down and see that lysyl oxidase might have existed in the Precambrian. But I pointed out in response, and this was the final point of the debate, that even if lysyl oxidase had existed in some hypothetical Precambrian form of life, at some point you need the genetic information for building that protein, and all you've done is push the problem of the origin of genetic information back a little bit in time without explaining how the genetic information arises. What is the mechanism that produces new digital code in DNA? Marshall doesn't explain that, and for multiple reasons that I explain in the book, it's a big problem in evolutionary theory today.